Hello, in this video we are going to define positive and negative angles. We'll also learn about the properties of similar triangles. Let's start with angles. An angle is generated by rotating a ray from its initial position to the terminal position about a fixed point called the vertex. If the initial position coincides with the positive x-axis and the vertex coincides with the origin, then you have the angle in standard position. If the rotation is counterclockwise, the angle is defined as positive. So here, the angle alpha is positive. Look at the direction of the arrow. It is counterclockwise. If the rotation is clockwise, then the angle is negative. Here, angle beta is negative because the rotation is clockwise. We usually denote angles by Greek letters like alpha, beta, theta, and phi. However, you are free to choose any variable to represent your angle. Angles can be measured in radians, degrees, or revolutions, and you should be able to convert from one unit to another. To do that, you will need to remember these conversion factors. That is 2 pi radians is equal to 360 degrees, and that is equal to 1 revolution. Let's look at an example. If you divide 2 pi by 2, you get pi. And 360, when you divide it by 2, you get 180. That means that pi radian is equal to 180 degrees. What about 1.36 radians? Would it be more or less? Because pi is 3.142, 1.36 radians is less. So you say that if less, more divide. That means you are going to have 1.36 radian divided by pi radian times 180 degrees. Remember, radian will cancel radian, so your final answer on the right hand side will have the unit of degree, which is what you're looking for. Now, when you do this computation, you're going to get 77.9 degrees. Therefore, 1.36 radian is equal to 77.9 degrees. You should be able to use these conversion factors to change from one unit of angle to another. If you want a higher precision, you can write the unit of angle in degrees, minutes, seconds form. To do that, you need to keep in mind that 1 degree is equal to 60 minutes and 1 minute is equal to 60 seconds. Let's look at an example. Convert 21.52 degrees into degrees, minutes, seconds form. To do this, we are going to convert the decimal part of the degree, which is 0.52, into minutes. Then we'll convert the decimal part of the minute to second. So let's start. We know that 1 degree is 60 minutes. Therefore, 0.52 degree, which is less, will be less compared to 1 degree, will be 0.52 degree over 1 degree times 60 minutes. This will give us 31.2 minutes. Now we are going to convert the decimal part of the minute to seconds. So we will start by saying that 1 minute is equal to 60 seconds. Therefore, 0.2 minutes should be equal to 0.2 over 1 times 60 seconds. And that will give us 12 seconds. Therefore, 21.52 degree in DMS form will be equal to 21 followed by 31 minutes followed by 12 seconds. Two triangles are said to be similar if they have the same shape but not necessarily the same size. Two important properties you need to remember about similar triangles are these. The corresponding angles are always equal and the corresponding sides are proportional. We have two triangles here. If these two triangles are similar, then angle A1 is equal to angle A2 and angle B1 is equal to B2 and C1 should be equal to C2. So the angles are equal, but the sides are not equal. They are proportional. And you can say that A1 over A2 is equal to B1 over B2 is equal to C1 over C2. That is, this side A1 over A2 should be the same thing as B1 over B2, and likewise should be the same thing as C1 over C2. These properties you need to remember about similar triangles. If we have this angle in standard position with 2 points P and Q defined on the terminal side, we get two similar triangles. That is, we get triangle OPR and triangle OQS, subtending at the same angle theta. Because they are similar triangles, I can write an expression for the sides, and that is, I can say that y over b is equal to x over a, because sides of similar triangles are proportional. From this, we can rearrange and have it in the form y over x is equal to b over a. That is, I have swapped the position of b and x. We are going to use this property of similar triangles to define the trigonometric functions in the next video.